All right, team. So 8G, part of your notes, there is really only one formula to take down, but two terminologies that you will need to sort of get familiar with. And very easy. Nominal interest rate. So in this exercise, they ask you to understand what is nominal and what is effective interest rate. Okay? Nominal is what you've been working with. You know that where you have 3.75% per annum? That's called nominal interest rate. Okay, so what you get as your annual rates, so it's compounded interest rates are usually quoted as annual rates, then those interest rate per annum is called nominal interest rates. Okay, so if you happen to see a question where they talk about nominal rates, don't get confused, they're just telling you it's the yearly rate. Okay, then what is effective interest rate? Well, when you have a loan, the effective interest rate of a loan or investment is the interest earned after 1 year expressed as a percentage, which is a key part there, of the amount borrowed or invested. Sounds confusing what they're trying to say? In 8G, they're just trying to say the amount that you borrow, what would be the overall percentage extra that you either owe or whether you gain from that. So why is that important? Every bank has a different product. They have different interest rates for a different amount of years. You know, it's hard to look at one thing and say, yep, this one's better. One of the best ways is you need to kind of do the comparison between each one. It's like when you go to Coles and you want to buy, I don't know, soft drinks. They usually have different tags on each one, different prices, but then you notice that the cans or drinks that you want to buy have different volumes. So which one is bang for buck? The best way to do it is at each tag, if you notice, they already have a ratio for you. They tell you how much it is per 100 grams. So that's your measurement. Yeah, that's your sort of level playing field where if this is $2 for 100 grams and the other one is $1.30 for 100 grams, then you know which one is cheaper. But if you're just looking at each product, one is 300 grams for a tomato sauce for $2. One is 500 grams for $3.50. Is it cheaper to buy the $2 with only 300 grams, or is it cheaper to buy the $3 with $3.50 for 500 grams? So that's where it gets confusing. So same thing with interest rates. There has to be a way to calculate which one is going to be your best choice, right? So this is what we call the effective interest rate. It allows you to change it to a percentage so that you can compare. If one is 6.5% and the other one is 6%, great, go for the 6%. No one wants greater interest. No one wants to pay a lot of money. Everyone wants the more minimal the interest rates, the better. Unless you're gaining, of course. Unless you're gaining, then you want that interest rate to be inflated as much as possible. So here, there's a formula that you'll need to copy. Okay, so that's the formula for effective. So I'll break it down what they're trying to say here. This will be the rate, your effective rate in percentage. Okay, so this will all be calculated as a percentage. You will get a rate through this formula. What is this R? This R over here is what we call nominal rate. What is nominal rate? That's your rate per annum. That's all it is. So for those who are sort of mathematically inclined and want to know how this formula works, logically it makes a lot of sense here. One is 100% of what you borrowed, say $6,000. Plus means this is the rate. So R over N, N being if it's compounded monthly, compounded daily, compounded weekly, or compounded yearly. That's why it's divided by N for the rate. So this over here just tells you how much you're adding on to what you initially borrowed. And it's compounded based on N, right? So then why is there -1? So the -1 is once you calculate this percentage, so say it's 1.5, right? 1.5 to the power of N. Whatever that result is after 1 year, 1.5, remember, it includes the 100%, which is what you started off with. You borrowed $6,000. If you only want to know the interest, you don't need the $6,000, which is why it's minusing 100%. Whatever your total is, minus the 100%, and you're only left with the interest. So this is left as an interest, times it by 100% to change it, the interest to a percentage. That's all it's doing. It's just saying calculate the overall interest and value minus the value that you started off with, times it by 100% to change it to a percentage. That's all it is. Okay, so in this exercise, you'll find that question 23 or example 23, they just want you to understand that if it's compounded per annum, which means per year, how do you convert this into monthly rate? Well, that will be 3.6 divided by 12, because you're compounding 12 times in a year. What about fortnightly? How many fortnights are there in a year? I've already put a sort of a summary for you. For those who don't know their quarters and fortnights and weeks in a year, this is what you should know. There are 12 months in a year, 4 quarters in a year, 26 fortnights in a year, 52 weeks in a year, and 365 days in a year, ignoring leap years. Okay? So that's just a part of a general sort of understanding. That's common sort of knowledge that you need to know. And that's all you're doing in example 23. What's example 24? I'll do a video on this one, but essentially this is your typical scenario with effective rates. You borrow $20,000. There are 2 companies. Should you borrow option A, 5.95% per annum, compounded weekly? So every week you'll have to compound it. Or is it better to go with 6%, so a higher interest rate, but it's compounded quarterly? Which one's better? How do you know? That's what this exercise is to get you to do. If you can change them all to an effective rate, you can then do a comparison and say,